Awesome. Well, welcome everybody. Good afternoon and good evening, wherever you might be when you watch this. A quick intro here. By the way, congratulations, you now own App Security. So Matt and I will walk through this. But before I get started, a quick intro for me. My name's Randy Pagels. I am a principal trainer at Xebia. Been in the app dev space about 35 plus years or so. And I'm based out of the southeastern Michigan, north of Detroit. I specialize around training, so building content, delivering training, anything GitHub related, GitHub Copilot, Microsoft Copilot, advanced security, etc. So that's what this session is going to be about. I'd like to introduce Matt. Matt, go ahead, introduce yourself.
Hey everyone, I'll turn my camera on for a minute here. Hey, so my name is Matt Olson. I am a senior consultant here at Xebia, based out of Tampa, Florida. If you're familiar with the area, there's an Air Force base about a mile or so behind me. So if you hear cool sounding planes in the background every once in a while, don't worry, I'm not being invaded for a change. I have a pretty broad background in the IT space. I've done app dev, cloud infrastructure, data center infrastructure, network security, application security. And lately, my focus areas have actually been around integrating application security and AI, kind of in both directions, securing AI and what it's able to do and not do, and also utilizing AI in order to enhance an organization's application security posture. And yeah, this is going to be a lot of fun, as you can tell by the graphics on this slide. So
yeah, awesome. Hey, one thing too, Matt and I like it interactive. If you have questions, throw it in chat, raise your hand, make comments. We have a small group here. But happy to answer any questions you might have as well. Let's go ahead and move forward here. I'll turn off my camera to save on bandwidth. Always a good idea. So before we jump into the GitHub Advanced Security story, I want to set the stage with a simple story. This is Gino. If you recall Gino from last webinar, well, Gino, he now runs this busy gelato shop. And like many businesses, he needs his website to move faster, serve customers better, and keep up with this high demand of gelato serving. But as Gino quickly learns, one of the gaps, or once his app becomes part of the business, its security becomes part of the story as well, which moves us into this slide, talking about sweet success to security wake-up call. Well, Gino does make an incredible gelato, but it's so good that the line seems to never end. So business is booming, orders keep coming, and Gino realizes he needs help keeping up. So he turns to his 15-year-old son, who doesn't, who basically offers to bring the shop online and create a web presence for it. So great idea, right? Well, mostly. As Gino's shop is doing great, big success comes with pressure. So long lines are forming. Customers want online ordering. Gino needs help fast. His son steps up and says, "Hey, I can build a website," right? Which is both heroic and just a little bit dangerous. Now, Gino's son, 15-year-old, they move fast. He gets the site working, he adds some code, pulls in open source packages, and even hard codes a few credentials here and there, air quote, just to keep things moving. The problem is quick fixes can create long-lasting problems, especially when nobody really is checking for security or checking the code. He's moving so fast. So then trouble hits. The site's compromised. This is when things go wrong. Orders are disrupted, and Gino realizes the shop has a real security problem. What started as a simple online ordering project now becomes a business issue, and that gets everyone's attention real quickly. This is what Gino expected customers to see: wonderful flavors, delicious toppings. And here's what Gino expected to see online. So customers can choose, of course, the normal gelato flavors, add toppings, build their ice cream. They can build cones and waffle cones and things like that, and something delicious. So from Gino's point of view, the site looks clean, friendly, and really ready for business. And then trouble hits. This is what customers actually saw, and it smells a little off. So trouble hits, the website's hacked. The website gets hacked here. As you can see, these are not delicious flavors or toppings, but we can see the problem. The site still works. It has the appearance, and customers have that experience that something has changed, but it's not really what customers asked for. So earwax and boogie and vomit and dirty socks, etc. They're not Gino's finest flavor lineup at all. So it's a fun example, but the point is serious. A security issue can quickly become a customer experience issue. Doesn't mean it breaks things. It just means it's an issue. So what's hiding in the code? When they look closer, they find the usual suspects: exposed secrets, vulnerable dependencies, risky code patterns. They're still sitting there the whole time. The issue wasn't just one mistake. It was that nobody had visibility into what those were hiding and where they were in the code base. So this is where GitHub Advanced Security comes in. Instead of guessing, Gino now gets visibility into the real problems. He has secret scanning, which helps find exposed patterns of passwords and tokens and keys before they create any trouble. He also can turn on push protection, which will help stop supported secrets from being committed into the first place. Also part of the suite is dependency management, which helps identify vulnerable packages and keeps the application current. Lastly is code scanning. So code scanning takes a deeper look into the code itself to find risky patterns early. So now the story becomes much simpler. Find the risks, prioritize the work, and start fixing the issues before they turn into the next late night disaster. Okay, let's take a look at each one of these. First one, secret scanning. This helps catch hard-coded tokens, passwords, and keys that never should have been in the source code in the first place. As we mentioned earlier, accidentally moving fast. Gino's son checked those into the source control system, which become part of the commit history forever. So for Gino's son, this is a moment he learns that convenience today doesn't, it becomes a cleanup tomorrow. So let's go take a peek at that. And this is where I'll hand it over to Matt to demonstrate the secret protection as well as push protection.
So yeah, here is the Gino's Gelato website. And as you can see, today's featured flavors are not looking good, right? I don't know about you. I don't want my gelato to taste like dirty socks. So what happened? Well, the first thing Gino did is he enabled secret scanning because he heard, that's the easiest way for people to get their foot in the door and really mess things up. And secret scanning, once enabled, showed about 20 or so secrets that were immediately found. Secret scanning, what it does is it doesn't just scan like the tip of what's there of your branches. It actually kind of goes back in history, which is really cool. And you can see here, there's a lot of secrets that are being exposed on the stronger, or what GitHub calls default patterns. It's a lot of SQL connection strings because they're kind of scattered throughout this code base. There's also an Azure App Directory or Active Directory app secret. There's a GitHub Pat token that's been exposed. There's a lot of stuff in here that's really not good to be spreading around. And if I look in here into one of these, I'm going to go with the Active Directory secret. The first thing is it's going to tell me where the secret is. So I can see it's in my app settings.json file, line 7. And if I go into this, it's going to tell me what the secret actually is that's exposed. This is kind of a little counterintuitive. The reason they do this is because it's already been exposed, right? Like your developers already see it. Now, not everybody can see secret scanning alerts. Don't freak out. The only people who can see secret scanning alerts by default are repository administrators, organization administrators, the person who pushed the secret, and also security managers. But the remediation steps here are a little bit manual, and this is the only tool in the GitHub Advanced Security arsenal that is highly manual. The remediation steps are rotate, revoke, check your logs, and then close the alert as revoked. And the reason that it's manual is because if I've rotated and revoked my secret, it's useless now. I don't have to go clean up old commits anymore. Just the password or the API key or whatever, it just doesn't work anymore. So it's just, tech debt sitting in your code. it actually kind of becomes useful a little bit if you continually monitor your logs and see if somebody's trying to use that to break in. And in the security world, we call that a canary. But it's a fun tactic that we use to kind of monitor if somebody's trying to do something malicious or not. But it's manual because GitHub doesn't necessarily know if you've done those steps: rotate, revoke, check your logs. GitHub doesn't know if you've checked your logs. They don't know a lot of the time if it's been revoked, if it's been rotated out in your application configuration. So that's why it's a manual process. And you can see here, it's going to tell me what commit this was pushed in. And you can see I did this one a couple hours ago. But this is not the latest commit in the repository. This just happens to be the first commit where it appears. And this is why I say don't worry about cleaning this up, because what I would have to do is amend this commit, which would rewrite history going forward from this point. And that's kind of messy when it comes to Git repositories. There are a whole bunch of secret scanning patterns, as there's a whole document of them. And then you can also add your own custom patterns here. So an example of custom patterns is my SQL connection string that I'm using. See, it even says detected custom pattern. The reason the SQL connection string is a custom pattern here is because there's so much variation on what a connection string can look like that it's hard to catch all of them. And also, like, not everything has to be in the right order and stuff like that. So just as a result, they're going to be a little finicky. I just happen to have a pattern sitting that will work for connection strings pretty well. You'll also notice some of these alerts here. Here's a PAT token, for example. Some of these alerts will be able to tell you if it's active or inactive. GitHub worked with the partners to have access to API endpoints to then figure out if a secret is active or inactive. And this is just a good idea to understand, like, how critical is it that we have to revoke this, and you can utilize that to figure out level of criticality here for these. In this case, this is an inactive PAT token. You didn't think I was going to give you a real one, did you? So that's secret scanning. What about push protection? Push protection, the goal behind push protection is to stop these alerts from ever having to be created. And the idea behind it for me is this: it's a guardrail, not a barrier. Think about this. How often have you been working on something? You're writing some code, everything's working great, you commit it, you push it, you had a hard-coded secret that you were going to go clean up later that you forgot about. You've just exposed a PAT token, a password, some kind of a key, whatever, and, well, now what, right? It's exposed. Now you have to go and validate that. You have to treat it as if it's been exposed to the world, right? Even if it's on a private repo, just treat it like everybody has it. Do you really want the entire world to have keys to your front door? I don't. So how does this work? Well, I'm going to show you this on GitHub. I'll explain verbally where this works a little bit differently off of GitHub. The experience is actually very similar in both places, slight difference. So all I'm going to do is add to any file. I'm going to take another PAT token, because I have a collection of these. I'm going to try to add it to this file. This is also another old PAT token, so sorry, guys. And I'm going to try to commit these changes. It's going to ask me if I want to make a new branch because, obviously I can't commit straight to main, right? That would be unheard of. I don't know why it thinks I'm removing a token, but cool. And I'm going to propose the change. And GitHub is going to stop me from pushing the change. If you're doing this outside of github.com, you're doing it in an IDE, it would look similar. I'm going to modify the file. I'm going to do a get commit, some kind of pithy message, and then a get push. And I'm going to get a error back from GitHub that the pre-receive hook that runs on GitHub blocked the push. And it's going to tell me exactly why. There was a secret found. It's a GitHub pat token. It's in this file on this line. And it's going to give me a link to go to bypass or submit a bypass request. That page is going to present this box right here. So small difference, kind of the same experience. This pop-up box right here would be the only thing on the other page. And it's going to allow me to bypass push protection. Depending on how your organization or repository is configured, you can either allow that kind of behavior or not. And it's going to ask me, it's basically going to say, hey, you really shouldn't do this. You should consider removing this from your commit and the commit history. Now is the time to go do that amend before you push it up to GitHub and expose it. But just in case GitHub is wrong, it's going to allow me to bypass it. And it's going to ask me, why am I trying to bypass it? It's used in test. It's a false positive. I'll fix it later. You know, if I'm saying I'll fix it later, it's actually going to open another alert and leave it open. If I say it's a false positive or it's used in tests, it's going to open an alert and immediately close it. So let me show you what that looks like. So I'm going to say this is a false positive, and I'm going to allow it. Now I have to commit the changes again. And okay, sure, I'll open a pull request. Why not? So now I've bypassed push protection, right? That pat token's out there. Let me show you what just happened. So if I go to my secret scanning results here, you're going to see I now have a closed alert. And what happened? Well, here's 18 seconds ago, somebody pushed a pat token. And here's my pat token. It was detected. It hasn't been verified yet. I can click the button and let GitHub do that. And here it is in the README file. And in the audit trail, you can see this is my GitHub account. I bypassed push protection. GitHub opened an alert, and then I closed the alert as a false positive. This is all audited. You're not operating in a vacuum here. And more importantly, this also appears in the organization audit logs and can be audited by a SIEM or a source system or anything like that further down the line. So how do you have ownership over application security with this? GitHub is giving you the guardrails. GitHub is giving you the detection mechanism for finding these secrets in your code. And they're also giving you the audit history for when somebody bypasses the security mechanism, so that security team, you can kind of follow up as a separate activity. But they've implemented this into the developer workflow. They've shifted it basically as far left as they can without putting something on your development workstation. And now you have the visibility into this. So you know where these things are. Oh, and where does AI play into this? Got to talk about AI, right? This generic category here is mostly going to be detected by AI. So what's happening here is AI is going through all the files in the code base and trying to figure out what looks like it could be a password. Or some sort of a key, and then reporting on it here. They're a little bit lesser precise because it's AI kind of saying this looks like it could be a password, but just understand that's what these generic ones are. They're not tied to a secret scanning pattern themselves. But same thing applies here, right? What's my mechanism for doing this is it's going to be, number one, triage it, make sure it actually is and it's not a false positive that, you know, looks like it could be, and then rotate, revoke, check my logs to make sure that nothing malicious happened, and then close the alert. So with that, Gino is now able to remove those hard-coded secrets from his code base to prevent some of the unauthorized stuff from happening to the Gino's Gelato website. Back to you, Randy.
Thank you, Matt. That was an awesome demo. All right, we will continue our story. So next up is dependency management with Dependabot. So Gino's site depends on packages he didn't write, open source. And of course, as we know, some of those do include security vulnerabilities. What's nice is Dependabot helps spot these risks and even suggest updates, which means that Gino's team can spend less time hunting and more time fixing. So now Gino has this a clear view of the vulnerability dependencies, and the next step is find them and fix them faster. So he wants to resolving these Dependabot alerts with AI. Dependabot will raise the alert, and the AI and cloud agents will go ahead and help work through the remediation, update the packages, adjusting code whenever and wherever needed, and then preparing changes for review. Keep in mind the important takeaway here is the developer still stays in control, but all the heavy lifting is done and gets a lot easier. So with that, I'd like Matt to show that off a little bit. Go ahead, Matt.
So yeah, let's talk about dependency management. So there was a study out there that shows that a majority of an organization's code base is dependencies. It's probably about 80% or so. The problem is you own all of their all of their vulnerabilities in your code, right? You're using somebody else's code, but you still own the vulnerability. So what Dependabot aims to do is bring that to a more visible place in a developer's toolset. So again, I'm in GitHub. This is what a developer would see. And if I go into my security and quality tab, I have a Dependabot category. And wow, there's a few vulnerable dependencies in here from all various categories. And this is not a big project. It's a small Vite.js website and a small .NET Web API is all that's here, and then some Playwright tests. And I've got 76 vulnerabilities in this repository. Now, some of these vulnerabilities are development dependencies, meaning that they're kind of developer tools. They're not, you know, pushed out with the main code base. They're basically shared for the developers. Some of them are, some of them actually do get built with the application. Say, for example, Vite would get built with the application. It's a Vite website. There's also this concept of direct versus indirect vulnerabilities, or dependencies rather. Direct dependencies are if I go into, in my code base here, if I go into my, wrong one, my package.json file, these right here are direct dependencies, meaning they are things that I directly depend on. But if you've ever worked in an open source ecosystem or with an open source package, you know that direct dependencies have indirect dependencies. They have dependencies for the dependencies, and then those have dependencies, and those have dependencies. And if you've ever looked at a package lock file and wondered where like a lot of these extra things start to come from, that's why. A lot of them are actually transient dependencies or indirect dependencies. The problem is you still own the vulnerabilities in those because it's still in your code base, right? So that's where you'll see on some of these this direct tag. And the direct tag is actually easier to fix. So we have detection. How do we have remediation? So there's two ways to fix a Dependabot vulnerability. Way number one is Dependabot is actually going to try to fix itself using a GitHub action that's going to basically try to just update the package manifest, or this is a JavaScript dependency. No, this is a NuGet dependency. It's going to try to update the package manifest file, either a package lock or a package.json or a package reference in .NET World or whatever. And it's going to open a pull request. In this case, this pull request that would be opened would actually fix 3 Dependabot alerts on this Azure.identity package. How does it know how to fix it? GitHub keeps a database of vulnerable dependencies. It actually keeps the biggest database of vulnerable dependencies. They call it the GitHub Advisory Database. The advisory database entry for this vulnerability looks like this. It's going to tell me some things here. So it's going to tell me, first of all, here's my package name and ecosystem, what versions are affected by this vulnerability, where was it patched. So anything under 1.10.2 is vulnerable to this RCE vulnerability, and it was patched in 1.10.2. It's also going to give me things like a CVSS score, EPSS score if it has one, what weaknesses are exploited. So this is CWE 77, which is improper neutralization of special elements used in a command, so command injection. If there is a CVE ID, it'll give it to me. Not everything has a CVE ID that is vulnerable, and there are some things in the advisory database that they just didn't need a CVE ID, but they're still reported. This is the ID for how it's stored in GitHub's database. You can go look at the source code, all that stuff. And if you want to browse the database, there's a lot of stuff in here. So what Dependabot's going to do is it's going to look at those patched versions for the vulnerability that's being reported in your dependencies, and it's going to go to the earliest version. So not necessarily the latest version of the package, but the earliest update that it can make that is no longer reporting vulnerabilities. So that's why I'm going from 1.7 all the way to 1.11.4, because 1.11.4 is the earliest version of this package that does not have any known vulnerabilities in the advisory database. And then Dependabot opened a pull request, which I can get to by clicking on this green button or by going through my normal pull request route. And from here, it's a normal pull request. I can see it's making a package reference update here. It's actually adding it as a package reference so that it hard pins the package to that version. So this was probably a transient dependency. And then all of my PR checks run as normal. So I have a build and test PR check that ran here. I also have an automated dependency review PR check that runs. So I'm, policing Dependabot on its own. And I've also got CodeQL checks that run to make sure that I'm not introducing code scanning vulnerabilities, which we'll talk about in a minute. And from here, I can just merge this PR. I have pretty good confidence that it's not going to break anything because I ran my build and test suite. I ran my vulnerability suites. I can run linters. I can do whatever. So let's put some AI into this, though. Everybody likes AI. So the other way that I can fix one of these Dependabot alerts is I can assign it to Copilot. And I have one here, Axios. Anybody heard about that lately? That I assigned to Copilot, to the Copilot agent. And the Copilot agent picked up this Dependabot alert and agentically iterated over, coming up with a fix. So it goes and looks at the alert, what's the next best available update, and then it's going to also make sure that contextually it makes sense. It's going to run its own Copilot code review steps and that sort of stuff in this case. And then from here, it opens a pull request. And in this pull request, it's going to describe what it changed. And from here, it's just a normal pull request. So again, it runs my dependency review check. It's going to run my vulnerability checks, my build and test suite, etc. So there's two different ways to do it. One of them is going to be a little bit less agentic focused. One of them is going to be a little bit more agentic focused. And there's pros and cons to both, especially with the change coming to AI, GitHub's AI billing. So we've talked about, again, detection. We've talked about remediation. In this case, this is, pretty cool, right? GitHub is basically helping you do the remediation for you. So as a developer, I don't have to worry about it. I have to know what it's doing, but I don't have to stress over going and finding the package. And in the agentic case, I don't have to worry about going and fixing any of the breaking changes that come as a result of that. It's the advantage of the agentic one. What about prevention? What if a developer tries to push a pull request out there that has a vulnerable dependency in it? And I kind of staged one for us, this one right here. So in this case, I'm adding a package, Minimist, version 1.25 to my package manifest file. And it looks, and I'm also adding newtonsoft.json here. And obviously this is staged, but this looks pretty innocuous, right? It's not a huge deal. There's two things right off the bat that'll give me a pretty good idea of what's going on. So I'm looking at a package JSON file, and this to me is like, okay, somebody's adding a dependency. But with GitHub Advanced Security, I also have this option to display a rich diff on my package JSON file. And if I look at that, this one's actually okay. Let's see, which one does it find? If I look at it, I can see now that newtonsoft.json file has a few problems in it. And that's not great. The other thing that I can do with this is I can also take a look at a tool called the dependency review. What dependency review can do is it's a pull request status check that basically looks at the software bill of materials delta between your default branch and a newly generated software bill of materials for this pull request branch. And it will fail if there's something vulnerable in the PR branch. So you saw this dependency review comment here, and it found I'm trying to push a vulnerable package. This is a big deal, right? As a reviewer, I'm coming in here, I have a comment that says there's a problem. Not only that, it's actually trying to tell me that Minimist package is vulnerable. I don't know why it didn't show up on the other place. It has a prototype pollution attack vector, which can actually be kind of a big deal for a web application. The other thing that I can do is add a rule set that says that if this dependency review check does not, that's why NuGet didn't run correctly. If this dependency review check does not pass as a status check, I can't merge the pull request. See how, like, I'm the owner of this organization. I'm the owner of this repo. I can't click this merge button. Doesn't matter how many times I try. What I have to do is fix the vulnerable dependency first before I can merge this pull request. So now I've got detection. I can find them. I've got remediation. I can fix them using AI or having Dependabot make the package manifest change for me in an automated manner. So as a developer, it's way less disruptive to my normal developer flow. And I've got prevention. I've shifted all of that stuff way to the left so that the vulnerability never made it into my code base. And if the vulnerability doesn't make it into my code base, I don't have to go back and fix it later. So with that, back to you, Randy.
Thank you, Matt. That's awesome. Great tooling, great AI, and great Autofix. That's awesome. All right, let me go back to my screen here. Continue our story. So finally, the third feature here is finally we get to code scanning. So this code scanning helps uncover risky code patterns and any and security vulnerabilities inside the application itself. So for Gino, it means his son can still move fast and still move forward, but now he has guardrails. I air quoted that. And that's a lot better than finding bugs after hackers do. So from chaos to control with campaigns is once the issues are visible, the next challenge is getting through them. Usually there's a stack of technical debt, and a lot of teams spend a lot of time trying to figure out how to find time to fix them. So that's where campaigns help. Instead of staring at a giant backlog, Gino can now organize their remediation and focus on the most important problems first and prioritize what to fix and make steady progress without drowning in alerts. But wait, there's more. With Autofix and AI, now the story gets even better. With Autofix capabilities, some security issues can be remediated faster with AI assistance. It's not magic, and it's not perfect, but it helps Gino and team clear the backlog faster and spend more time reviewing their manual chasing than manually chasing down every single fix. So to see campaigns and see code scanning, I'm going to turn this back over to Matt for some awesome demos.
Okay. So code scanning, GitHub's code scanning tool of choice is CodeQL. And that's what I'm going to show today. Just a little caveat in here about that. You can also bring your own code scanning tool. As a rule of thumb, if it can output a Serif file, it can then be ingested by code scanning and then be displayed in GitHub. And I've actually worked with clients before where we're combining a few different vulnerability scanning tools in order to have a much different picture, especially when you're looking at languages that CodeQL doesn't support. Today, I'm working with JavaScript, TypeScript, and .NET, or sorry, C#. So all of my languages are supported by CodeQL, so that's not a problem here. To get to your code scanning results, they're once again in the Security and Quality tab. I know, right? This is a shocking thing. And they'll be under code scanning. And you can see, well, Gino's son didn't do, he tried, bless him. Could have done a little better, but it's all right. There's 42 things that Copilot found here. And they're going to be ranked on severity, high, medium, low. I think they're all highs and mediums in here. But this is a developer-friendly dashboard. I know it looks overwhelming when there's a lot of things in here, but these things in here are fairly easy for a developer to understand. I'm just going to pick on this one just because it's fun to pick on SQL injection. It's my favorite. This is what a code scanning alert looks like, generated by CodeQL. Your mileage may vary a little bit if you utilize another tool. It's based on how the Serif file is constructed. what I can see here is it doesn't like this SQL.toString line here, and it's saying that there's a SQL query being built from user-controlled sources, aka a SQL injection attack vector. I get the tool that it was detected by. I only have CodeQL running, the rule ID, and then what's kind of cool about CodeQL is all of the queries that are run by CodeQL are open source. CodeQL is actually its own language for building these detection queries, and it's not only useful for detecting vulnerabilities, you can detect a whole bunch of other stuff in code. In case you want to see what this query looks like, it links you straight to the SQL injection.ql file, CWE89, inside of the C# suite, and this is what it looks like. And you'd have to learn CodeQL to understand a lot of what this is doing, but just know they're open source. It's a community-powered tool, and you can actually extend it with your own queries if you like as well. Then I get this description here, right? If a SQL query is built using a string concatenation, the components include user input, a user is likely to be able to run malicious database queries. Gee, I wonder how all of my flavors got changed. I wonder if those are coming from a database. And by the way, it's a lot of bad flavors here, just to let you know. I mean, do you really want sardine flavored gelato? I don't know about Randy. I don't want sardine flavored gelato.
No.
And then I have this show more, right? So this is like what I like to call, if you remember newspapers, above the fold versus below the fold, that concept. I just aged myself. Sorry, guys. But if I click on this show more, I get what I like to call the below the fold text, where I get a recommendation, maybe get a little bit of an example here, a little bit of a code example, and a lot more text, some references. Usually there's a link to the MITRE website, which if you really want some dull reading that'll put you to sleep at night, MITRE is the way to go. There's a lot of good information out here, but it's not as entertaining as Gino's Gelato. Even with their funny diagrams with frowny faces. But then I also get some other stuff here, right? So show paths. So pathing is important to understanding a vulnerability, because if I don't understand the entire string of how something is vulnerable, I don't necessarily know where the fix is. For example, SQL.toString doesn't really sound vulnerable, right? I'm doing a toString on probably a string builder or something like that. But if I show my paths here, I can understand how I get to this vulnerability. There are some times where there's multiple paths available for something to be vulnerable. In this case, there's one path, which is kind of nice. And it's going to start at the beginning. Casey, I'll like my comment there. I'm going to start at the beginning, and it's in my get method here. I'm getting this string called search from a query string. Okay, so this is now my user provided data, right? This is like in a URL. This would be the query string, and it's looking for a string with a key of search and then some kind of a value. And so then what I'm doing is in this if block, a little bit further down in the method, is I'm appending SQL.append. So this is a string builder. And I'm just injecting that into my SQL string. I'm not parameterizing it or anything like that. I'm just putting it in the middle of my string. Okay. Now I'm starting to get a picture here of why is this a vulnerability? And it's appending it to that SQL string. And then what I'm doing is running my DB context against my user table from SQL raw. So it's not parameterized. I'm not doing anything to it. I'm just blindly passing a string into that method and getting data back from it. So now I have the entire path of why it's vulnerable, not just there's this vulnerability that's here. It's explaining why. And now I understand I don't actually have to fix this. What I actually have to fix is either this append right here, or I should probably consider not using from SQL raw and using a parameterized query instead. And as a developer, I now have that context. So I've got detection. What about remediation? I'm going to go to one where I haven't done this yet, which is basically all of them. Wrong button, Matt. And all of these are going to have, from CodeQL, and this is going to expand to other security tools in the future, they're all going to have this assigned to Copilot button. What this is going to do is take the context of this vulnerability here. So it's going to give this file path, the error, the CodeQL rule, all of this text that would appear in here, and it's going to feed all of that into Copilot. And it's going to tell Copilot, go fix this. Come up with a solution that solves this problem. And what Copilot is going to then do is return a recommendation of how to fix this and give you the option to open a pull request. Full transparency, I'm in an organization where I have a couple of feature flags turned on, and I'm going to show you guys a little bit of a preview feature here for that assigned to Copilot button, as long as Randy promises not to tell on me this time.
Promise.
There is a preview feature for, I've already talked to the Microsoft folks. I'm actually okay to show this. There is a preview feature that also does this agentically. It's a work in progress. It's by far not perfect yet. I just happen to have it turned on in here because I've been messing with it for actually conceptually for a client that may want to use this as well. So when I click on the Assign to Copilot button, it actually goes and launches the Copilot Cloud Agent with all of this information, runs a sub-agent, and then that sub-agent opens the pull request. So it's a little bit different, but it has more context over the entire repository and a couple of other advantages for that. And that is what I did for the for this guy right here. So you can see here, it was detected. I clicked on the Assign to Copilot button, so you can see I have an assignee, and it opened it in a pull request. And here's the pull request. So this was a log forging attack vector in an auth controller. What's funny is I chose the one that I didn't want, or I chose the wrong one for this, but basically the auth controller is writing user-defined data into the log file. And in theory, that means that as a user, I could potentially inject anything I want to into my logging mechanism. And so now I can kind of exploit a vulnerability chain, which is why you don't want to do that. Sanitize what's going into your logs. And if I look at, like, I can go look at the agent and what it did here. So full transparency, it ran, went and grabbed files. It actually ran a whole bunch of stuff through the sub agent, ran some checks, and then created the pull request. And that pull request is this one. Inside of this pull request, it's a regular pull request again, right? So now I have dependency review ran. Hey, look, I'm not adding any vulnerable dependencies. That's good. I have a nice comment for what it did. So it's adding sanitization for this user.role. I put a whole bunch of vulnerabilities in here. It also ran my build and test suite, and then it also on its own runs CodeQL again. So I'm agentically fixing a security problem by using an Autofix agent, and then I'm using my security security scanning toolset to make sure that it is actually not just fixing that problem, but not introducing another problem. And that's important, right? Because sometimes the agent, what it'll do, and all these tools that auto remediate, they'll fix the problem that you tell it to fix, but they sometimes might do it by introducing another vulnerability. So I'd rather find it here. So we've got detection, right? I mean, if I run a security tool and I don't get vulnerabilities in my code, either my code is that good or I probably need a new security tool, right? Imagine if your alarm system at your house, somebody breaks in and your alarm system just doesn't go off. You'd probably be getting another alarm company, I hope. And then I've got remediation. I'm going to show prevention first before I show a little bit more on remediation. So what if I try to push vulnerable code? Well, as you saw, CodeQL is running on my pull requests. That's a default setting for the default configuration of CodeQL, is it will run anytime a pull request is targeting the default or any protected branch. So Gino's son, not me, obviously, Gino's son decided to try to add a search endpoint to be able to search for flavors, right? Because in theory, they're going to have a whole bunch of flavors, more than 42, if y'all get that reference. And they want to have some kind of a search functionality here. And that's great. Okay, so again, we're just going to do, select star from the flavors table where the name of the flavor equals whatever, or the description of the flavor equals whatever. Seems simple enough, right? Okay, so we wrote the code, pushed it in. There's no dependency review stuff because there were no dependency changes, but it still ran. And as a reviewer, I can see that. And oh, what's this? GitHub Advanced Security found a problem. And, well, remember that whole SQL injection thing? Yeah. Same thing here. So in my pull request, before my code was even merged in and scanned in my main branch, I found a problem here. And it created a comment in the pull request itself saying, hey, I found something. Not only did it find something, but it has a suggested change that I can commit to the pull request if I like this change. So what this is now doing is instead of doing a raw SQL injection, it's going to do some interpolation here. So it's doing an interpolated string with the name of the flavor there, and that, in theory, should do some sanitization. And if I commit this, CodeQL is going to run on it again to make sure that Autofix actually is suggesting something good. And you still get the pathing thing here. So, I can see here name is a query string that's being passed in. It's then being set in this SQL string. That SQL string is then being passed into my raw SQL statement, and there's no sanitization, and there's my injection attack vector. The other thing about prevention on this is, remember how on dependency review, I stopped the pull request from being able to be merged? Well, same thing here. Merging's blocked. I can't click this button. I can't even bypass being able to click this button. I guess technically I could, but I can't click this button right now until I fix that result. The reason this is important is there was, again, I'm going to quote a study. There was a study done that showed that security vulnerabilities, like code scanning vulnerabilities even, that make it into the main code base and don't get fixed on an emergency basis, sit on a product backlog for about 8 to 9 months. So for about 8 to 9 months, if this wasn't an emergency fix scenario, I would have potentially a SQL injection vulnerability in my code base. As an attacker, I have all the time in the world. 8 to 9 months is a really long time, especially with AI, where I can just tell AI to try to find attack vectors on a website. Claude is a really good red team assistant, by the way. So now I have prevented the vulnerability from getting in. This vulnerability never made it in. It's not going to sit on my backlog anymore, because as a developer, I now have to fix this before I can mark the task as done and ready to be tested, right? That's kind of the idea. And it's in my normal developer flow. It's in the pull request. I didn't go anywhere else here. It showed up in the pull request. One last thing here about, well, two last things, I guess. First of all, there's a lot of things here that are showing up, right? There's 42 open code scanning alerts. It's a little overwhelming to look at for some people. So how do we fix that? We want to solve these in a organized manner. We want to pick the most important things first, identify them, and have a way to highlight them to the team of, this is important. These are the vulnerabilities that I want you to focus on first. How do we do that? We have a tool called campaigns, and I happen to have created one earlier for Gino's Gelato. What campaigns are is basically apply a filter to your code scanning results, and that's your campaign. So in this case, in this campaign, I basically said, from this specific repository, only take the high severity vulnerabilities and apply them to the campaign. Campaigns are at the organization level, so you can actually go across the repository boundary with those. I'm sticking with this one repository for here because I have a lot of vulnerable repositories in this organization. So in this campaign, I can actually see some cool things here, right? Who's managing it? Randy and I. What is this? It's a demo campaign for Gino's very insecure gelato shop. And then I can see progress. There's 2 alerts that I've dealt with that have been closed. There's 2 that are in progress, and then there's the rest of them are open, right? So that's what, 16 open. You get like a little bit of a dopamine hit when you kind of close that progress bar down. It's kind of fun. I can see also, I put a due date on it, right? It's due by the 29th. So by the 29th, I want to resolve all of these alerts. Or sorry, by the 29th, my security guys want to have all these alerts resolved. Same thing. But there's another cool feature here too. When I, and again, so full disclosure, I have that feature flag on. So my experience is a little bit different right now. When an alert is included in a campaign, Autofix automatically runs on it. So I don't have to go click that button anymore. And if I have reviewed a selection of alerts and I know the Autofix is good on them, I can just create a new branch, throw all the Autofix results in that branch, and open a PR. I happen to have that feature flag turned on, and I have this assigned to Copilot button. And what that's going to do is take these alerts, and you remember how I had that assigned to Copilot button before? It's going to do the same thing, but it's going to do it with multiple alerts. And you can see I did it for these two guys right here. These two SQL injection attack vectors. Are you discovering a pattern that I really like picking on SQL injections? I assigned it to Copilot, and it created a pull request to solve both of the problems at once. So now, agentically, without having to leave GitHub, I have assigned this to the Copilot Cloud agent and said, I have these vulnerabilities, please go fix. And here's kind of an overview of what it did. So in the auth endpoint, it replaced SQL raw with a link predicate over users, probably the smarter move there. In the user controller, it replaced the string builder and from SQL raw with some better search semantics using, I think, the like function. Yeah. Yeah, that's what it did. And I can come in here and I can see what it did in the files. You know, it's a regular pull request. So now I am the one coming in and approving this. This code looks good, I'll approve it. It's a regular pull request, again, so all of my pull request checks run. Dependency review included. I have dependency review set to always include this comment. And it also still ran my build and test suite for PR validation, and it still ran CodeQL over the code in the pull request in order to ensure that it's safe. So now I can merge this and I can close those vulnerabilities in the campaign. So that's where campaigns are really good with targeting the more important things that you want your developers to fix. And then, hey, developers, you own fixing it. Congratulations. As a little bonus, CodeQL, I said it's not just for vulnerabilities, it's also for code quality. So for example, in my JavaScript, I have some unused imports, variables, functions. There's a couple things in here that just aren't used. For example, in this JavaScript file, I'm supposedly not using path. I didn't realize that. In here, I'm not using this total flaky variable. I actually don't know what that is, but I'm not using it. So again, I can assign these to Copilot to go generate a fix for me. So I'm not only improving the security posture of my code with CodeQL, I'm also helping to improve the quality and maintainability of my code with CodeQL. So now we have detection. I have detected the vulnerabilities. We have remediation. I have used AI or myself. I mean, you know, sometimes AI is not perfect, to fix the vulnerable code and introduce a pull request that runs through all of my normal pull request processes for validation and actually security review. And I have prevention. I stopped a vulnerability from ever making it into my code in the first place, which means that I don't have to worry about going back and fixing it later. And I don't have to worry about living with a vulnerability in my code. So with that being said, Randy, back to you to finish this out.
Thank you, Matt. Appreciate that. You are doing a fantastic job telling the Gino story here. I'm going to go ahead and share my screen. Bring it home. All right, so let's get back to serving gelato and doing it safely. Now that Matt has showed us and demoed the backlog and code scanning and campaigns, etc. So at the end of the story, Gino is where he wants to be. He wants to be serving customers and growing the business and not losing sleep over these security surprises that he has seen and his son has shown him. So now the backlog is down, the process is better, and his son continues to build and just a whole lot better with a lot better guardrails now. Security is a team sport. So the big takeaway is simple. Security works best when it becomes part of everyday development in the developer workflow, not a last-minute scramble. So with the right tools, even a fast-moving team led by Gelato shop owner and his 15-year-old son can build safer software and sleep a whole lot better. So Matt, on behalf of Matt and I, we want to thank you both. Thank you all for coming to this webinar. Appreciate you hanging in there